Professor Nitin Saxena is a leading voice in theoretical computer science with groundbreaking work spanning computational complexity, algebra, number theory, and cryptography. A BTech and PhD alumnus of IIT Kanpur, he is best known for his role in the breakthrough Primes is in P paper, recognized globally with the Gödel and Fulkerson Prizes, along with the Shanti Swarup Bhatnagar Award. As the coordinator of the Center for Developing Intelligent Systems and the founding dean of the Wadhwani School of Artificial Intelligence, he now leads research and AI innovation aimed at solving challenges in the local economy. Welcome, sir. Thank you so much for giving us your time and talking to us today.
Yeah, thank you for inviting me.
To start off with, you've been associated with IIT Kanpur for more than 2 decades. So from an undergraduate student when you came in 1998, completed your PhD in 2006, and now today we are sitting in 2025 and you're a professor here. Tell us how this association has been throughout.
So in 98 I came here after passing JEE, and then in 99 I joined the Computer Science and Engineering department, so I started my courses and work here. And I graduated, finished my BTech in 2002. So in those 3-4 years, initial 3 years was, it was not clear what I wanted to do or what will I do.
Okay.
So that was just kind of directionless. But towards the 4th year, and especially towards the end of the 4th year, I was focused in exactly the things that I liked. So that way I would say that my BTech time gave me a lot of structure. And then that structure has actually continued and it has improved over time.
Right.
It was everything else that happened builds on top of that structure.
Right.
So in that sense, there has been continuity in those 25, 26 years. That doesn't mean that the institute has not changed and I have not changed. So institute has changed a lot.
Yes.
So it has, in my time, whatever it was, now it is, if not 4 times, at least 3 times.
Right.
In all senses. Faculty, students, infrastructure, projects, interaction with the government, and so on. So the system has grown a lot.
Right.
And with that, I have also grown a lot.
Absolutely, absolutely. So in your you've mentioned once before that in your early days you were already quite interested in algebra and maths. So how did that, like when was that point when you thought that this is my career and this is where I'm going to go, or this is what I want to pursue further?
Yeah, so since school days, not before class 8, but after class 8, I remember in those 3 years, 4 years of school, and then after that when I joined IIT Kanpur. So after class 12th, I immediately came to Kanpur. So in all those years, the continuous thing was that I was interested in algebra, number theory. Initially, I was interested in geometry, but geometry you can exhaust pretty fast.
Okay.
So after geometry, the challenging things were actually in algebra and number theory, and those were those things come first because they are easy to state, and so you see these problems already at school level.
Right. Yeah.
And since I had, after class 8, I had developed an interest in this symbolic notation and abstraction in contrast to, let's say, humanities and history and geography. So instead of that, I was much more interested on the math side, which also then became related with computer programming and so on.
Right. So what does the symbolic mean in this? Can you just?
So symbolic just means that instead of using words and sentences, I would prefer to use equations.
Oh wow! Okay.
Yeah. So equations, I preferred that language more over long sentences and essays.
Right.
Which is what students are taught in school. They have to write a lot.
Absolutely.
Yeah, so I had very little interest in those things.
Right, right. Yeah.
But I had interest in understanding and expressing in terms of equations. So algebra is a natural thing to do for these students. Yeah, but this was, the interest was also partly, it had a romantic nature because I had read many biographies of mathematicians and scientists.
Okay.
Like starting from thousands of years ago to European Enlightenment era, which is 300 years ago, 400 years ago. So those mathematicians from the biography, these are usually glorified. So that is how I kind of got more interested about not just math and science, but also the history of science and math.
Anyone in particular?
But
who
I
may
did not
have-
know what I can do in that.
Right. Yeah. Anyone in particular that may have, you think, touched?
Oh,
your-
everybody. I mean, all mathematicians and scientists who are known.
Okay.
I read some part of their history
Okay. Yeah.
during this time.
So, in just dialing back a little more, when you were in school, what kind of a student were you? Were you the kinds who would bunk classes or always get straight A's?
No, in school there was no option of bunking classes because I mean I have to go from home to school. So there is no
Right.
in the same city.
So
Parents
everyone
are
gets
there. creative.
creative in bunking classes.
Yeah, but so till class 8 that option was not there. But maybe
Right.
after class 9 that option is there. But by that time I was already too serious in my stuff.
Right.
So the bunking and other activities were not of great interest to me. At the same time in the class I would get bored because most of the subjects were boring. So it's
Yeah.
not that in the class I was very active.
Hmm.
So I only liked physics and maths and maybe literature, English literature.
So, since all of this would have a lot more opportunity once you come to a UG and a college space,
Yeah.
tell us any like interesting story from your UG time.
Oh, interesting story. I don't think I prepared this answer. There is
Well-
really there is no specific story. I mean, I was close to my wingmates, so we would whatever we would do in the hostel in my wing. I was close. I mean, there were some 13 or 14 rooms, so 13 or 14 students
Okay.
of my batch of across all departments,
Okay.
most of the departments. So I was like close to them, and we would all the social activities were with them. There is no specific interesting story. I mean, obviously, the students or my batchmates with whom I started working, some of those projects became big.
Right.
Like in the final year, I started working with Neeraj, and I had actually worked with him in earlier projects also. But this last one was to do with algebra, number theory questions, and that became quite big.
Okay.
So, yeah, but there is no specific anecdote.
Okay. And any extracurriculars or anything apart from your academics that you were involved in? Any clubs or?
No, I was not involved in organizing extracurricular activities, but things which would happen in the campus in my batch, like hostel events, cultural events in the institute. I would attend some of them.
Yeah.
Yeah, but I was not really into the organization of them.
Okay. Okay. So also once before I've read you said it was simple algebra that we worked with.
Yeah.
What is so simple with this algebra that makes solutions to such complicated problems?
Oh, well, so generally, if you attend thesis defense or talks that students or even faculty give, they are always presented and laced with very complicated terms. So, I mean, academicians in general like to present things in a very complicated way.
Right.
So, in contrast to that, all the things that we do or we did are simple.
Okay.
In the sense that we can actually present the problem statement in simple words, and to an extent we can also present the solution in simple terms.
Okay.
It doesn't mean that you will understand them,
Right.
because each
Which
word
we
will be
won't.
simple.
Yes.
Yeah, each word will be simple and each concept can be simplified, but then how the whole thing is invented, that will still never be clear. So the whole thing may seem like a miracle unless you are familiar with that genre. So in that sense, it's simple. So we even now, like I train my students in that also. When we give talks, we try to keep things as simple as possible, but not simpler.
Right. Yeah.
Yeah. So instead of the other way, which is make things more complicated.
True.
And so even so at least the main results in the papers, the first page, that somebody who is interested should be able to understand.
Right. Makes sense.
Yeah, so that is the meaning of simple. So all problems are actually of this type,
Right.
unless presented badly. So
Correct.
all the problems, so this is the second part of your question, that why do simple problem and simple solutions become important? It's because actually all our problems which we pose and which are open are of this type. So you can present it potentially in a simpler way. To some extent, obviously, after a while, the proof will become complicated or algorithm becomes complicated.
Absolutely.
But
Yeah.
starting points are actually simple.
Okay. Yeah. So you yourself had also mentioned, and of course you've made so many great contributions, groundbreaking results have happened at an early age in your life. So how did you and your partners in the work and all deal with things like the sudden popularity, the sudden limelight? Not just popularity, in the sense of that, but you do get attention, you do get the focus and the notice. How did you all deal with that, especially after the publishing of Crimes and Pay?
Yeah. So that was around 2000. I mean, towards the end of, or in fact, end of summer of 2002. So there was no good way to deal with it. It's basically, I mean, in real time you have to react to it.
Right.
And then we were also, or I was, I just finished BTech. After the convocation, this happened.
Right.
So the PhD has not even started. Yeah, it hadn't started.
Right.
So I think for me the main thing to deal with was now how will I do anything in PhD? Because if this is the standard which is set,
Right.
then what other problems you can work on in PhD, and whether anything will happen, and then after PhD what will happen. So there is a high ladder that you have to climb, and if
Yes.
you are already at that stage, then it seems impossible to climb any further. So that was the thing. But over time, I started working on other problems, then ultimately also started working with other people, then started working with students, especially when I was in Europe. So as the groups expands, the bag of problems expands,
Absolutely.
techniques expand. So then the initial stress, or how do you deal with the psychological pressure, that reduces. I mean, you learn how to manage all that.
Absolutely. Yeah.
So now I can manage many things.
So how did you then from there go on to pick your PhD problem?
Yeah, that was not easy. No, there is no set way to do that. It was just, I mean, in the general area, there are many problems which are open, and there are intermediate approaches known to them. So I would read with other students and with my advisor, or in Princeton with other faculty also, other students, other researchers. We would read these things, we try to understand, we'll present them. And after 1 or 2 years, something small which is new happens.
Right.
So then you build on that.
Sir, I now want to know that a lot of times when anybody sees success from another person, you most often do not realize what's gone behind it, and it's very easy to just to say, oh, this person has just kind of found it. Nobody looks behind it. But what goes behind so much of, like, what is the hard work that goes behind getting to some achievements like this?
So hard work, I think, is hard work and success. So these are the things which other people see, because they don't have actual interest in the work that has happened.
Okay.
So I think hard work and success are just kind of things that tag along. Main thing for me is, or the person who creates or who wants to create something, there has to be a genuine interest in that.
Right.
Now, where that genuine interest will lead and how it will lead towards the goal that the person wants to achieve, that happens step by step. And there are the things that I think will happen generally doesn't happen. Something else happens.
Yes.
So you have to deal with that.
Okay.
And then whatever else happens, you try to maximize it. So how do you navigate this? So the navigation will happen only if you are actually interested in that general area.
Right.
If you are interested in only one problem and nothing happens there,
Yeah.
or let's say one problem, one approach. If you are only interested in one approach and it fails, so then after that you have nothing else to do.
Right.
So you have to have a interest in the whole activity and the whole area.
Right. Makes sense.
So that is what really goes on in any kind of human endeavor. When you remove the success and the hard work. I mean, sure, for hard work you will do, but then to what end?
Right.
So there has to be so the end and the inspiration or the motivation is your core interest.
Right. Yeah. So now you've also set up this Center for Intelligent Systems. So from algebra to AI and intelligent systems, can you walk us through this journey?
Yeah. So this is a joke that my friend makes, with whom I run the Center for Developing Intelligent Systems.
Yes.
That I mean, AI is not my area, and I originally was not really interested in practical problems. But then he, partly as a joke, he wanted me to head the center.
Okay.
So that he can tell everybody that now I am doing AI. But I don't do that.
Right.
I mean, I only do it in a sense that I discussed with other people who are engineers or who are MTech students, who are actually working on some corner case of AI, and then we try to see whether that has utility somewhere else, which is basically our client. So the center is a client product focused center. It's
Right.
not so much about research and publications, but what idea or what theory can be used and deployed so that the client is happy.
Right.
The goal is actually it's a client facing activity. So in that I help, and whatever management is needed, and also this guesswork that okay, if client wants something like some AI product or some app or some analytics, then who is the best? What is the best technology? Can it be done cheaper? And so those kind of decisions. How long will it take to solve that problem?
Right.
So those things I do. I guess it requires somebody who has technical experience, because if you bring up a person who doesn't have technical experience or let's say hates maths, then the interaction with the students and the engineers is not possible.
Of course.
Yeah. So maybe what the client needs can be understood, but then how do you translate that and inspire students and faculty and even engineers? Because what they do is really, I mean, these programs, they are complex objects, and the models are even harder. The models are essentially statistical models. They use algebra, they use geometry, they use many things. So one ideally wants to go into the detail to some extent.
Okay.
It is not possible to remain completely outside.
Yes.
Yeah.
So this has been, like you said, on the client side, but now you're also getting into the education and student side with it,
Right.
with the upcoming School of
Right.
AI and Intelligent Systems. So how does your role fit in over there?
Yeah, so one point I forgot to make for CDIS is that it was not just like I and my friend who wanted to start this, but there is this big demand from the government side and then from the institute side that there should be some organization that takes up projects and then delivers.
Right.
So for that, what is needed? You have to maintain engineers, you have to pay them very well, so that from the market we can actually get them. Because software engineers and AI modeling experts they are already paid so heavily outside.
Absolutely, yes.
So bringing them here and keeping them motivated requires a different setup. It's not possible to do it in a traditional department.
Yes.
So there was a need. So for 3 years we ran the center, and in the middle, since we quickly became successful, so then the other need also needed to be satisfied, which is now you want to train people. You want to train people differently than what is being done in the IITs in traditional departments,
Right.
and especially in IIT Kanpur here. So we wanted to kind of expand this CDIS philosophy at the academia level.
Okay.
So for that we need a department. So we created a department proposal, and then ultimately we or the institute found a donor who wanted a school. A school is an umbrella body which mainly has this academic organization, which is the department, and then these implementing arms, which are the centers.
Right.
So these centers are Center for CDIS, cybersecurity, robotics, AI policy outreach, and something called advanced AI.
Okay. Yeah. Going away from this and just back to your problem solving, sir. When a problem is presented to you, I want to know what is the process in your head that goes through about tackling it, and what are the steps towards getting into a solution?
Oh, so the research problems that I work on with my students, generally this takes, to get anywhere, it takes several years.
Absolutely.
So we cannot tell you the secret recipe in few minutes.
Absolutely.
But overall, if you compress those many years into few seconds or minutes, it's basically you look at the problem, you try to match it with something you already know very well. So that of course will not completely work, because if it already reduces to a known problem, then other people would have solved it.
Correct.
So you will map it to some known problems and solutions, but that will not work. So then you start studying why is it not working. So then you get into other problems, and so it's an iterative process. So you reduce it, then you fail, and you iterate. So after this iteration, so after every iteration, there has to be a distillation process where you write down what have you learned. So after several iterations, and also with some amount of luck, you can get to a good solution.
Right. Yeah.
But the good solution, as I said very early on in the interview, may not be of the problem you started with.
Correct. Yeah.
It will be of something else.
So as a professor, you've also been a student here, you know the system, you know what students want, not want, what they think, how they look at a professor, especially in the same ecosystem and scenario. So what from that understanding do you bring to your teaching today?
No, so I think this knowing the students, being a student, I don't think that is what, I don't think those are the inputs which I'm using in my teaching or mentoring.
Okay.
No, this is, obviously, once I have gone through that experience, the way it has helped is I am familiar with the system. I'm familiar with the how instructors instruct, how students take the instruction, and then how do you mentor, and how do the PhD students perform or don't perform. So I've seen many examples.
Right.
But that just seeing these examples is actually not enough. So as I said, earlier also I said to some other question, the reply was essentially of the type that you have to form a style, and you should have an opinion, form an opinion, and basically be interested in certain topics. That interest is what I try to convey.
Right. Yeah.
So if I'm teaching, and I teach these courses which are very advanced, other than the basic courses which every faculty has to teach, we also have these advanced courses. So when I'm teaching these advanced courses, which is related to my advanced research or area, so there every chapter has some intuition, something which I like.
Okay.
Those through examples, those are the things which I try to convey.
Okay.
So it's a very technically focused activity.
Okay.
Now, if the student body or the body of students or the people who are in the class, if they like that stuff,
Right.
then it will resonate.
Right.
If they don't share the interest, then it will not resonate.
Correct.
So it's actually a misconception that if I teach it very, very well,
Yes.
then everybody is inspired.
Yeah.
That doesn't happen.
Right.
So even with the best form of teaching, I'm only talking about advanced courses, obviously. At the level of school, you have to play differently.
Yes.
So there, because the things are very simple and everybody has to learn ultimately, let's say English language, they have to learn how to add numbers, so that's non-negotiable. But in my area, things are negotiable.
Right.
So it's not that advanced stuff everybody has to learn equally
Absolutely.
well.
Yeah.
So people who are not interested in it, they drop out.
Right.
So I try to only inspire people who actually share the interest. So um, the important point is that people who are interested, they should not get demotivated.
Right.
Yeah, if people or students who are interested, if they come to a premier institute like ours and they get demotivated, then we are failing.
Yes.
But
True.
people who are not interested, if they get demotivated, I think we can't do much in advanced
They will
courses.
probably not anyways be able to take it further
Because their
much
interests
in
are
life.
somewhere else.
Correct.
Yeah, so it's actually fair to them that they should then focus on something else.
True. Yeah.
Yeah, so it's not exactly the things I've experienced as a student, because I guess in those days you don't understand these things.
Right.
All courses look equal.
Yeah.
And I already had very fixed interests. But now, with seeing all these examples, I try to just keep the motivated students or interested students more and more interested.
Got it. Yeah.
Yeah.
Nice. So you have studied and worked with lots of different universities and lots of different countries. How important do you think is this mix of exposure of different environments, different people, different setups to broaden your horizon or to eventually, affect the way that you think and then you take the work forward?
Yeah, it has, for me, it has been extremely important. So as a student, when I was doing PhD, I was here only for 2 years. The other 2 years I was abroad.
Oh, okay.
Like 1 year I spent in Princeton, then another year I spent in Singapore. But then after submitting the thesis, I went to Europe. So first as a postdoc in Amsterdam, and then as a faculty in Bonn, in a center called Hausdorff Center for Maths. So those experiences, especially the Bonn experience, was extremely helpful because it is important that you have worked in multiple premier venues. So the things that you missed in one place, you can see the effect of that in other places, and then you can pick and choose and you can form your style.
Right.
So in Bonn, for example, I was interacting closely. In fact, I was a part of the math department, and it has the best math students in the country.
Okay.
So these students I was able to inspire. There was good frequency match. They were interested in learning the computational aspects, and I was interested in learning pure maths, which I had missed. And then, so this interaction helped a lot. I actually graduated 2 PhDs and multiple diploma and masters and even
Yes, sir.
undergrad students. So yeah, that mix of different departments and different cultures was actually helpful. So when I came back, immediately I was able to actually work with students and form a big group.
And what made you come back to IIT Kanpur?
That is, so I was, and I still am interested in visiting other countries, but I don't think I have found a place where I actually want to settle for life.
Okay.
So that place has only been the place which I'm most familiar with, which is India.
Right.
So probably, and even in that actually, probably north of India. So when I applied back, I only applied to the places in the north.
Okay.
So I guess this was, I was probably too regional to settle anywhere else.
Okay.
Yeah, but obviously, but the other thing is that professionally also you should have opportunities. So
Right.
in my case, the opportunities were available and I was able to attract other people.
Right. Yes, sir. So what is the problem statement you're working on right now?
Oh, right now there are, in my research there are a number of problems. I have a number of students. So usually every student works on a different problem. I will not go into the technical details of the problem or the problem statements even. Just that they have this common theme of computational algebra.
Right.
And computational models. So we work with, so the questions are about computational models, whether something can be computed in a model or whether something will take a long time to compute. So whether a problem can be solved fast or it cannot be solved fast. So proving either way. So the first problem is the problem of finding algorithms. So I work on many problem statements where we try to design actually algorithms which are faster.
Okay.
Like solving, so factoring polynomials, modulo, prime powers. So we are actually trying to find a fast algorithm. And there are other problems where we try to show that fast algorithms don't exist. So those are the lower bound problems. Similarly, there are problems of finding algorithms for geometric problems.
Okay.
So we are doing algebraic geometry
Okay.
in those problems. Yeah.
Okay. And if sir, a student wants to get associated with you either through a research project or student under you, get mentored under you or work in CDIS, how do they come and impress you?
Oh, so CDIS is different. In CDIS, they have to show interest in actually doing implementation and be interested in making the product simple enough that it can be used, it can be tested, and it can be sold. I mean, if nobody uses it, then I guess CDIS will not be interested.
Right.
So some actual problem of a actual, let's say, client or an agency, government agency has to be solved, and there are many steps. It's not everything is technical there. It's also about understanding what is it that other people want.
Okay.
And they themselves may not know what they want.
Right.
So we actually also have to formulate the problem properly for them, and then make something which fits that bill and make sure that it works in practice.
Right.
So that's a different skill. So
Okay.
there we test other things. On the theoretical side, so the mathematical research that I do there, I mean, with experience now, it's actually pretty fast. Like in a month or so, I get to know what is the level of the student and what is especially the level of interest of the student in my area. So once the level of interest is good and the student doesn't have any other, let's say, interdisciplinary issues, the student is committed. So the only thing to check after that is whether the student is interested in trying different approaches or many approaches. So one approach we discuss, it fails, then we have to find some other approach, and we have to keep doing the iteration.
Right.
So that is tested over several meetings.
Okay.
Yeah, but if your question was about the first meeting, I think in the first
just generally
meeting,
to another way of asking
Right.
how does one come and start working with you?
Right. So that is the first few meetings you are asking about. So there, then you don't have so much of time. I have not seen the student for long. So in that case, it's mainly about what is it that the student talks about, my problems. So I just tell the student that go through my homepage, look at the papers, read the half page, which is in the front, which is called the abstract.
Right.
So read the abstract of these papers and then come and tell me what interests you.
Right.
So looking at those answers, I screen.
Okay.
So students who are just here for killing time,
Yes.
it's very easy to
make that out.
Yeah, to basically screen them out.
Right.
And then the remaining ones are able to make a meaningful statement. So yeah, it's a good screening test.
Nice. Yeah. So we'll wrap up this section, and now from here we are going to take it on to a little bit of a rapid fire. So very quick questions, very quick answers.
Okay.
Yeah. First, you have to pick out of the two.
Okay.
IIT Kanpur as a student or as a faculty?
As a faculty, definitely.
And why?
Oh, but I thought it'll be only MCQ.
I know, but still interesting to know what you think.
Oh, as a student, I think there was always this big uncertainty, and there was always this thing that there are many things which I don't know. Obviously, resources are also fewer. But as a faculty, with all the experiences, I find that things are in more control. So I know I can work on more problems. I can work with more people.
Okay.
I can mentor more students.
True.
So I think the dimension. So instead of unidimensional, now it has become really multi-dimensional, and so in many places more impact can be made, which as a student, I mean, at least I found as a student, lot more uncertainty, and it was not clear where I can make an impact.
It's a great one. Yeah, yeah. Next one, sir. Research or teaching?
Research.
Okay. I want to ask you to elaborate. Teaching a UG class or mentoring a PhD student?
Mentoring a PhD student. Yeah.
Okay, yeah. No more picking. When you wake up in the morning, what's the first mathematical thought you have?
Oh, no, so continuously, I mean, most of the problems remain unsolved that I work on. Very few problems actually get solved. So one of these problems, whichever I am in that month or in those few months, wherever I think which seems most promising, I'm stuck in some detail of that problem.
Right. Yeah.
And it's always with the students. So there is some problem which I find that in these few months we are the closest to solving, or there is an approach which seems promising, or there is an approach which is unexplored even. It may not be promising, but it's unexplored. So I just want to see where the exploration takes. So those are the problems which are there 24 hours.
Okay.
Yeah, those are the,
Okay.
that specific problem is the first problem.
Okay. Any aha moment that you've seen from your students? Any student?
Yeah, many times. Yeah, I have graduated some very good students,
Okay.
both here and in Bonn.
Okay.
So the first problems or the second and third problems which they solved with me, many times there were actually aha moments, like things which I thought we are not close to, immediately got solved because there was some breakthrough understanding.
Nice. Yeah. One part of the job that you love the most?
I think the biggest thing, I mean, if I compare it with industry, I never went to the industry. I never cared for an actual job.
Right.
I always.
This is also actual job.
No, I have always worked in an academic setting, and I've always lived also very close to my academic office. And so when I compare it to what I see or what I hear from my friends and from students is, we here get a huge amount of freedom.
Right.
Yeah, so I think the most important part which I find is the freedom.
Okay.
So there is obviously some implicit pressure from the society and maybe even from the institute to do this or to do that.
Right.
But these are generally guidelines. So you still have freedom to actually pick your problems and pick your projects.
Right. And how about the opposite? One part of your work that you don't like to do? It could be in any sphere of the work.
Yeah, so anything which is where I am not discussing ideas, where I am just like there is something which can be mechanized or automated, or something which is not even needed, and then I still have to send emails about those, or I have to do meetings about those.
Right.
Yeah, so the supporting part of creative activity.
Right.
Yeah, that part is obviously the most boring stuff.
Right, yeah. And so you've mentioned many times that there are obviously at any given point in time many problems that you're working on, many problem statements that, if I ask you to pick one and say this is the one that I really want to crack, what will that be?
No, I mean the list of the biggest open problems is publicly available, so I can pick any. Yeah, but so the ones on which I have really worked on are again to do with computational models, which are circuits. So there is a computational model which is called algebraic circuit. So there are two kinds of questions about those. One is testing whether they are zero or not in deterministic polynomial time. So that is a problem which in the last 25, 26 years I've been involved with various collaborators solving many special cases.
Okay.
But the full problem is still unsolved.
Okay. Yeah.
Yeah, so that I have invested most of my time in trying to solve, and the other side is and so similar problems are there also in computational algebra. There are many problems in computational algebra which I have worked on, made some progress, but they are not totally solved. On completely other side are these questions about what can algebraic circuits not compute.
Right.
So there also I have thought about many models, made some progress with students and others.
Okay.
But that problem is also in general unsolved.
Okay. Great. And just last one, any words of advice for young scientists, young students who are getting into the field, or it's just your words?
Oh, general advice.
Yes.
So general advice is that you should get into this field only if you are highly interested. So commitment to a specific area of math or science is actually the first requirement. If you are not committed enough, then it'll be very easy to get disappointed or discouraged or even disillusioned.
Right.
So once you are really committed and interested in one problem, ideally for me, what has helped is that I, since like late school days, I knew that I am interested in only one thing.
Right.
So I would not even look at the choices. So if you are like this, then you will have no problems because you would know that you can only do one thing.
Absolutely.
And so there will be no issue of disillusionment. But if you are interested in many things and you want to decide that, okay, whether to go for pure research or not, or this problem or that problem, then for that the method is, which now I use because I work on many problems, is that you give a good fraction of time to problem one. You try to exhaust all the techniques that you can try, and if nothing works, then instead of getting highly disappointed, you just move on to the next problem.
Okay.
Yeah, so you basically allot some time and give yourself enough freedom. If it works, it works. Otherwise, you make a note that what are the things that don't work.
Right.
And you move on. So because you may not be able to crack it or solve it immediately or in that allotted time, but like if you are in this area, in your area, then after a few years, you may actually come back and solve it, because by then other areas would have given you confidence.
Correct. Yeah. Great. Thank you so much, sir. We'll end the chat today over here. Thank you once again for taking out the time and being with us over here today.
Yeah, thank you very much to all of you, also who are behind the camera.
Yes. Yeah. Thank you.